Hello everyone, welcome to Kafka Flink. So today we will discuss one of the most important concepts, like how the real-time data flow actually happens in the systems. Like you see, like the Zomato applications or any other real-time applications. So there, how the real-time applications actually, uh, where the ETL flow actually works. That actually mainly we will discuss. So first of all, we need to understand that what is ETL. So if you will know the ETL, that is very fine. I will appreciate it. And if you will not sure about what is ETL, so then the ETL is basically the extraction, transformation, and so now we will know like from where we will extract, how we will transform, and where we will load the data. So there basically one perfect source system will be there. After that, we will use some functions, or we can also use some tools as well, which basically do the transformation operation. And then we will basically load it to some target database or some data warehouse, something like that. So there we will basically load the data. So the real-time ETL means, like here you can see the real-time word, like this thing I have attached. So what does it mean? Like what is the real-time ETL? So that means continuously extracting the data from a source systems, transforming it as it arrives, and loading the processed data into one or more target systems without waiting for a scheduled batch job. So why we will use the Apache Flink for that real-time ETL with Apache Flink? So Apache Flink here basically it comes into picture like for particularly powerful for this real-time processing because it can process millions of events continuous while maintaining the state and handling event time operations. So we have to consider a proper business scenario. So suppose consider one e-commerce scenario. As we will discuss everything with proper examples like that. Okay. So consider an e-commerce platform. So every second, different systems generate events as and here actually we are using the Apache Flink because to handle those kind of event time operations. So whatever events will be generated, we will handle that with the help of Apache Flink. So as we are considering the e-commerce scenario, so they are basically in every second, different systems will generate different types of events. So one by one, I'm just giving you like what kind of events it basically generates. So suppose customer places order, that is one event, correct? The next is like customer suppose makes payment. Okay. Now next can be suppose product inventory changes. All are event. Okay. So that is one. Next, it can be like shipment status changes, right? And another can be like customer suppose browses the product. So that is also one event. Okay. So these are the events. This kind of real-time scenario we can see to create some events. So instead of waiting until midnight to process this kind of data, the business wants the data available almost immediately. For what kind of things? We want this for, here I'm just writing, like why we need this. So for, we need this for real-time dashboard, okay, for fraud, suppose some fraud happens. So we need to detect in real time, right? So for fraud detection, also it is required. Next, just think inventory monitoring. Okay, this pattern. Then suppose you are seeing one OTT platform, or suppose YouTube. So their real-time recommendation is happening. So real-time recommendations is happening. Next, there suppose some operations happens, but operational alerts required. So operational alerts, that kind of thing. So for that kind of things actually triggers. So that's where actually Flink based real-time ETL basically comes into the picture. Okay, I believe up to that part, whatever I have explained, you can understand that, right? Clear? Okay. So now I will just will explain you what can be the architecture is. Okay. So now we will explain about the architecture. So whatever like real-time systems actually we will work, that kind of one production architecture actually I will show you. So at first see, like as a basic architecture I've shown you, like source, then transformation, then load. But in real time, like in production systems or whatever systems are live actually, so how those things are actually being worked, you need to understand that also, right? Yeah. So first of all, like whatever source systems I have talked about, so there also some source system is there. But what kind of source systems actually? So what we were talking about actually. So this kind of source systems we can have the PostgreSQL or suppose MySQL. Okay, then our application also can be the source. Then some APIs. Okay, the APIs also can be our source. So you can consider that one block, the source system. Okay, so then we will have the CDC. Like through the CDC, actually the flow will be gone to what? To some Kafka topic. Okay, so to some Kafka topics. Okay, and then it will come towards the Apache Flink. I will also will talk about what is the functionalities of the Apache Flink. So it will come to the Apache Flink. So Apache Flink will do different works. So like it can work for transformation, so transform operations. Then it also can work for like filter work or like enrichment, like data enrichment. Then it can also do some join operations. Then it also can work for some data aggregation. Okay. After that, we also can consider like deduplication, any deduplications related work. Okay. So that can be also done by the Apache Flink. And then it will go to several kinds of target systems. Okay. So that also we will call out one by one. So like it can go to some data lake. You can consider the AWS S3 as the data lake. Next, it also can go to some data warehouse. Okay. So for data warehouse, you can consider several things. I can consider Snowflake or GCP storage. Also, you can consider according to your use cases. Then Elasticsearch, like how the recommendations actually work. The Elasticsearch, or you can also consider the OpenSearch. Okay, so these are the parts. And after all these things, like when it will go to the target systems, after that, it will go for the observability and for some BI, business insights, or some analytics purpose, right? So that can be the suitable architecture. Okay. So what we have discussed the fundamentals of ETL. Then what is the real-time ETL? Why we use the Apache Flink? We have considered the e-commerce scenario. What kinds of events can be generated? We have considered, and for what reasons we actually using. So that also we have discussed. Then one architecture I have discussed. Okay. Now step by step we will discuss more. So for as a step one, what is the step one phase? That is basically extract. Okay. So the first stage is extract. So Flink basically needs a continuous stream of events. For example, suppose an order is created. Okay, I was giving one example for Zomato order, right? So suppose that Zomato order has been created. So you can consider the structure of the data, like, or the data model you also need to consider. So for that, you can consider like some JSON. So there some ID. Order ID. Here order ID, suppose order 001. That is one order ID. So for a particular order, there is one order ID. Then the customer who gave the order, so that has one customer ID. You can think some C101, that kind of thing. Next, what can be the next thing? So it will give a order for a product, right? So there will be some product ID. Now the product ID, I'm just giving example, suppose P501. That is one product ID. Next, what can be? Just think, if the product, then for the product, the amount will be there for this product. So amount. So just consider the amount of the product is suppose 2500. Next, the status, like the status of the order. So it has been created. So we can set the status as created. After that, proper timestamp. Otherwise, we will not able to understand like when that order has been created. So suppose you can give the date, suppose 2026. It is suppose 08/28, and there will be some time actually 10, 15. Then suppose I'm giving the random time. So suppose 32. Okay, YYYMMDD time. There, the proper time in HH and SS. Okay, so that will be suppose one basic structure of the order. So the event could originate from an application database, or like you can get the information from an API, what I have talked actually. Okay, so that information we got actually. Then a CDC tool. What CDC tool we can use? So in my project work earlier, I have used Debezium. Okay, so Debezium is a very good tool. So that basically can able to capture the database changes, and that can publish them to the Kafka topics. Okay, so whenever like this flow you can consider like suppose our source system is PostgreSQL. Okay, so then whenever the data we will fetch will insert to Debezium, and from that it will go to Kafka topics. Clear? So Kafka now acts as the event backbone. Okay. So next step is it will go to the Apache Flink. So Apache Flink basically consumes that message. Okay. So our step one done, the extraction. Then through CDC, it will go to the Kafka topics, and from the Kafka topics, the data will be consumed to the Apache Flink. So as a step two, we can consider the Flink consumption. Flink consumes. Okay. So that part. So Flink consumes events from the Kafka. For example, suppose Kafka topic is order. Okay. Now, in the Kafka topic, there are several partitions. So partition 0. Partition 0, there some order events are there. Now, in the partition 2, like the second partition is the partition 1. There also some order events are there. And in suppose partition 2, there again some order events are there. As our topic is order, so always the order events will be there for each partitions. Right? So Flink basically distribute these events across parallel operations. How it is? So Kafka. So there are several Kafka topics, right? For and we are discussing about the topic order. Okay, and there are several partitions. Okay, so Flink basically distributes these events across parallel operations. So there, the Flink task one, then Flink suppose task two, and here Flink task three. So these allows the pipeline to scale it how horizontal. Sorry, yeah. So now we will do the step three. What is that? The transformation. Okay, so we will do the transformation now. So Flink basically transforms the raw data after consumption. So it will first the process in our architecture extractions happen, then step two is Flink consumptions happen, and then step three is transformation. So Flink basically transforms the raw data to some processed data. So just as an example, I will tell you. Let me change the color. Otherwise, it will look like same thing. Okay. Now see. Now suppose there is some raw event is there. Raw event is there, and raw event there. The structure just understand like that. There is some customer ID, and in customer ID, the customer ID like C101. Okay. And next we have the amount. Okay, the amount. Suppose it is 2,500. And next we have the country. Country is suppose India. Okay. So that is the raw event, or you can consider as the raw data as well. Okay. Now, through the transformations, the business may want some extra things like the currency. Okay. So we got the data, the country is India. So from that we can convert it, like we can get the currency of the India, right? INR. So we can do that. And also one more thing actually here. Suppose the source system, in the source systems, the data is suppose not full name, it is suppose I, yeah. So it is supposed I and N. Okay, like that. So from that actually we need to understand that the country IN means it actually India, and the country for the country India, the currency is INR. So we require that business data. So we need to transform that into in this way. So there the customer ID is the same. That is like we are not transforming this one. It is same as C101. Then we have the amount as well. Is same. We don't need to transform anything. Then we need to give the full name of the country. We need to give the full name of the country, which is nothing but India. Okay. And now the currency also we need to give to the business. So the currency is IN. Okay. So that is our required data for the business. So Flink can perform the field mapping. It can do the data type conversion. Suppose the amount it is in integer, but here we need to make it suppose double. Okay. So that type conversions, then data cleaning, then normalizations, business rule applications, schema transformations. That kind of work actually Flink does. Okay. Okay. So next part is step 4. So step 4 is for filtering. Okay. So not every event needs to go to downstream. We need to filter out some things. For example, like we have the order, we have to filter in that way. Like suppose order amount which is greater than 0, and status is suppose completed, not only created, and where country is suppose India. So Flink can filter the invalid events. So what can do? So some orders actually are there. Then uh, it will suppose it will go to like Apache Flink will consume those orders, and then the filtration work can be happened. Like whatever are valid, like what are actually fulfill this type of conditions that are valid. Okay, so those we will send to the data lake, and whatever are invalid, we will send them to TLQ, the data queue. Okay, so I hope whatever we have explained, you have understood it. Okay, so invalid records can be sent to the data queue for later investigations. If there's some change will be required, and after the change, the process need to continue, then again it will send to the Apache Flink, and then again Apache Flink will filter those. If it will be valid, then it will go to the data lake, and if invalid again, it will go to the DLQ. So here we can do the processing like that. So if DLQ, then some suppose some investigating team. Suppose I'm just giving the name as ASUS service operation related. Some team is there, so that they basically work on the data. Then again, it will send the data to Apache Flink, and this process will be continued. Okay. Now we will discuss about the step 5. What is basically enrichment? Okay. So this is one of the most important parts of the real-time ETL. Suppose the order contains this type like customer ID. I'm not giving the double quotes or like that. Just understand. So customer ID is suppose 101, and next your product ID is suppose P501. Okay, all are string types. Okay, the proper JSON type. So then the amount is suppose 2500. Okay, so but analytics require in that format. Suppose it will require the particular customer name, customer name, then suppose customer segment. Okay, then suppose the product category, next suppose region. It can require this type of things. Okay, so Flink can enrich the event using another data source. How? Now see the flow. Now there is order stream is there. Okay, now the data will be consumed by Flink. Next, there are several data, not only the order data. There are several data, several sources are there. So there are suppose customer data is there, and there is product data. Okay, so you can see here the customer name, customer segments, whatever these things required, it can get the data from the customer data source, and whatever product category region that can be get from the product data. So from these both two, the data will be enriched, and we can get the enriched data. And suppose in our case, our source data was like that, but through the enriched data, we can convert these to in that way that I am going to show you. Like what can be the structure as we require the customer names, customer segments like that. So we suppose had the proper order ID, some order ID was there. Okay. Next, we have had the customer ID. Suppose order ID was 0101. Okay. Now here the customer ID, so C101, it was there. Next, we now have the customer segment. Customer segment is like we already got that from the customer data. It is suppose premium. Okay. Now it can has the customer name. Suppose John. Right. Now it can also have the data of the product category. Product category is suppose some electronics product. Some electronics product. Okay. Next, like the amount was also already there for that order. It was suppose 2,500. But suppose we have configured to float type or double type. Okay. And the region also we got. Region also we got like East region. Okay. So see, like here our data, like the source data was like that. Only customer ID there, product ID there, amount was there. But now we got the data from other data sources and we have enriched the data with whatever required for the business. Okay. So here we have discussed what things. See. So transformations we have discussed. Transformations we have discussed. Filter we have discussed. Enrichment we have discussed. Now another one we will discuss. What we can discuss? We can discuss about the aggregation. So we have covered the step 5 as enrichment. So now step 6, it can be the aggregation. Okay. So what this aggregation means? So Flink can calculate the metrics continuous, right? So suppose the company wants like total sales for every 5-minute window. So there are several kind of events got generated, right? So we got the data as suppose 10.01. There the revenue generated for suppose 5,000. At 10.02, they are generated as suppose rupees 7,000. Then at suppose 10.03, generated like 10,000. Now at 10.04, suppose 1,000. Now 10.05, 2,000. Okay. So like total sales for every 5 minutes we need to calculate, right? So the total like aggregations means that one. So for every 5 minutes, suppose 10.01 to 10.05. So just need to calculate the total 5, 7, 12, then 20, 22, 23, 25,000. So we can say in 10.01 to 10.05, total sales or total revenue generated like rupees 25,000. So this is done using windowing. So there are like several kind of windows are there. So common windows we can also discuss. As that part came, so I will discuss about the common windows as well. So the first one is tumbling window. The first one is tumbling window. Okay. So what is that? So that means like each event belongs to exactly one window. Suppose these 5 minutes, one window, then again 5 minutes, another window, again 5 minutes. So each are like for 5 minutes. Here it is 5 minutes. Here it is 5 minutes. This is basically the timeline window. And if you were comfortable with the DSA, you have heard about the sliding window, right? Sliding window. So sliding window means windows will be overlapped. Like here, suppose we can consider for 10 minutes. Then again, from here to here, we'll consider the 10 minutes. From again here to this one, we will consider 10 minutes. So total timing is same. If you will see the total timing. So here see this part. So see, if you will calculate like from this to this, it is 5 minutes. Again, like this to this, it is 5 minutes. Again, here is 5 minutes. And again here from here, it is 5 minutes. So here 4 times, like 20 minutes we have actually calculated. So it's okay. But I'm just telling you, like some 5 minutes are getting overlapped. Okay. And there is another one, which is session window. So tumbling window, sliding window, and session window. So events are basically grouped based on user activity. Like when the user is perfectly active. So user activity based on the user activity. So user suppose generate some event, and some after some time again it will generate some another event, again some another event. Okay. So after that, here if we will continue the flow, here suppose user inactive. Okay. So if user inactive, then there will be nothing. So that sessions will be ended. And after that, again if it will come, then new sessions will be created. So it's totally session based window. Okay. So 3 types of windows also we got to know, right? Okay. So step 6 we have covered. Now the next step is step 7. Another color, let's choose. Okay, just pick that one. It's very similar type, so we'll go to that one. Let's see how it is. Okay, so step 7, it is like loading. Like for the ETL, we have come to the very last stage, extraction, transformation, loading. So for transformation, actually, I have discussed these mistakes like aggregations, enrichment, filtering, transformations. Okay, and last here we'll discuss the loading part. So after processing, Flink basically sends the data to the target systems. So target systems, I have actually told you what can be the target systems. We have the target systems as these things, right? This data lake, then it can be data warehouse, then it can be some Elasticsearch or OpenSearch. This kind of things are there, right? So now different consumers can therefore use the same process string, and they can do their business logics, or they can show the data to some stakeholders, whatever it is required. So that is basically the real-time ETL. Now we will compare one thing. What we can compare? We will compare basically the real-time versus the batch ETL. Batch ETL. Okay. So the traditional batch ETL, how it is? There can be some jobs, bad jobs, actually, some singular jobs actually runs. Okay. So suppose now it is suppose 12 a.m. Just consider it like that. Then the data extractions happen. Okay. Then the transformation happens. Then load. Okay. And load, after loading, it's happening suppose at 5 from the 4 a.m. the data is getting loaded. It will take, suppose if it is huge data, suppose 2-3 hours it's taking. And after data loading at 6 a.m. the data suppose available. Okay. So the business might wait several hours. Like see, from 12 a.m. to this 6 a.m., 6 hours. But if you will choose the real time, if you will choose the real time, then suppose at 10.01.01, some event actually suppose created. Okay. Now, suppose 10.01.02, Flink basically process that data. Okay. And at 10.01.03, that particular data will be available. That's why we will call that not exactly real time. We'll call that near real time. That's the particular perfect name, near real time. So the latency can be seconds or lower depending on the application. Now we'll know like where this Flink is really powerful, like where Flink really powerful. Okay. So the major advantage is that like Flink is mainly stateful. Okay. So Flink is stateful. So I have told you like suppose one example I was giving you like for that aggregation part, like 10.01, suppose 5,000 business sales happened for a customer, then 10.02 this one. So in that way, so Flink can maintain a state that total aggregations we got 25,000. We can maintain that one, and total transactions also we can do like total 5 transactions happen. What is the average? Like 5, 7, 10,000, 1,000, 2,000, total is 25,000, and you can divide it by 5. So we can get the average from that. Like average is 5,000 transactions happen, transactions timing, transactions like 5 transactions happen. So it is stateful. That's why we are getting that kind of data. So these state can continuously evolve as new events arrive. So that's difficult to achieve efficiently with a simple stateless ETL pipeline. This batch ETL is basically stateless, but this near real time, that one is stateful. That's the main difference. Okay, I think you got it. Okay, now we will also talk about the fault tolerance. So imagine Flink is processing, and for processing, there was suppose 1 million events are getting generated per seconds, and a worker suppose crashes, and a worker crashes. Okay, so you don't want to lose the processed states, right? So Flink basically uses the mechanism such as checkpoints. What Flink use? Flink uses checkpoints, right? So like Flink basically, I have told you that checkpoints it uses. But why it uses that checkpoint? For like periodically persist the application state. Yeah, that's the main funda of it. So if I will properly show you that suppose some Flink job is running, okay, some Flink job is running, and there is some state, then some checkpoint. Next, in that point of time, suppose it is there like another checkpoint. Next, suppose there is another checkpoint, multiple checkpoints, like each points we can consider as the checkpoints. Okay, so now there is some checkpoint storage. Checkpoint storage is there. Okay, so if a failure occurs, so suppose some failure occurs, or I was telling about some worker got crashes, so some failures, then it will try to restart. Then it will restore the checkpoint, and it will do the processing again. Like it will continue processing, continue the processing. So this is critical for enterprise data pipeline. So now I was working on another project. So that is basically one UK-based meter data management system. So there, actually, how it is being used, actually, I can tell you. So that was a practical enterprise system I'm talking about. Okay. So imagine a utility company processing smart meter data. One utility company. It basically suppose process. What is the function of it? It processes smart meter data. Okay. Now millions of meters continuously, and suppose 1.5 million meters appear and many. Okay. So there the data type is like in that way. So there is some meter ID. So suppose A101. Okay. Now there is also a particular timestamp is there. Okay. So how the timestamp it is that I've told you, suppose 10, 15, 32. In that way, suppose the timestamp. Next, there will be some consumption rate. Consumption rate is there. Suppose 4.8. It is the consumption. Then unit. It is suppose in uh, liters. Okay. So that is a practical example. So what is the architecture for that? So basically, there are some smart meter. So then there can be some IoT gateway. Okay. Next, it will come to the Kafka topics. Okay. And then the from the topic parallelly, the it is consumed by Apache Flink. Okay. So after that, there are many functionalities for the Apache Flink already we have discussed. So one is suppose validations. So validate the data. It can deduplicate the data. Then it can enrich the data, like the data enrichment from other data sources. Then it can aggregate the data. Okay. Next, it can basically detect anomalies, create alarm, like kind of things. And then it also can calculate the consumption. Okay. And then finally, it will send the data to some S3, then some data warehouse, suppose some EDP kind of things, and some dashboard for the data observability. Okay. So in that way, it actually works. So I'm just telling you here. So Flink, what is the role of the Flink here? Here I have told you, but how from the data that actually I'm now going to tell. That suppose for the meter, which is AM101. So generally consumption, generally consumption, consumption normally, I'm selling that suppose 4 to 6 liters. Okay. Now the current consumption is like suppose 25 liters. So that is basically potentially a abnormal things. Abnormal. So there can be some anomaly. Okay. So it will do some things. It can generate the alarms. So this is a very strong real world Flink with Kafka plus CDC plus data lake use case that actually I've told you. Okay. I hope you have understood that. So like whatever data structure or like the architecture we have discussed, again for some revision purpose, I'm just telling you. So we have discussed about, first of all, Kafka. Data source is okay. After that, Kafka. So Kafka basically, for what purpose we use? The event ingestion and durable event streaming. For event ingestion and durable event streaming. Okay. Next, we have talked about the Debezium, right? Debezium. So the Debezium basically the database change data capture. Database change as a CDC tool actually. Change data capture. Clear? Now, next we have discussed about the next technology is Flink, which is our main role or key area. So that is basically for real-time streaming or real-time transformation. And I have told you Flink is stateful, so stateful processing. Clear? Next, we have told about S3 or data lake. So that is basically the large scale historical storage. Right? Next, we have talked about data warehouse. So that is where we can do some analytical queries. Right? And next, we have also talked about Elasticsearch or OpenSearch. So for first search purpose, okay, for first search or like not or I can say it and like for first search and like some operational dashboards. Okay, so that kind of thing. So if you were asked like why would you choose the Apache Flink for the real time ETL? So you can tell like I would use the Apache Flink when the ETL pipeline needs continuous low latency processing of high volume events, and Flink basically provides the distributed stream processing, stateful computations, and event time processing. It also helps for windowing. Their windowing concept I have told, right? And also it has fault tolerance capacity through checkpoints. And also I have told about the scalable parallel processings, right? Here. Here I have discussed. Yeah. So suppose in Kafka topics the data enriched like data got, and then when Flink actually consumes the data, it can segregate it to task 1, task 2, and task 3, and parallelly horizontally it can do the work. So a common architecture would be like CDC from database through Debezium and Kafka, and followed by Flink for transformation, enrichment, deduplication, aggregation, and finally loading the process data into some data lake warehouse or some search systems. So always remember, whenever you will discuss this architecture, you will remember that this Kafka basically moves the data and Flink basically understands and processes the data. And data lake, data warehouse, so those basically stores the process data. So this makes the real-time ETL with Flink an excellent topic for any system design or some data engineering discussions or interviews. Okay. So I hope this content will be helpful for you. So do like, share, and subscribe to motivate me. I can make more such videos. Okay. Thanks, everyone. So source systems can be like different source systems can be there. So there can be like first of all, I am just giving some examples. Suppose PostgreSQL. This can be our source system. Like different kinds of databases actually.